Welcome everybody to Devlog 1 of a game I'm very excited to be working on. I'm attempting to make a semi-arena battler / roguelike based on gems. I've been procrastinating about making this game for a while now, with 2 failed attempts. Since then, however, I've built 2 games, admittedly with friends, but I believe I'm capable now of working on this project. Throughout this Devlog 1, I want to build a prototype of the game. I've made the mistake of working without prototypes before. It was not fun. I'm not going to do that ever again. So I decided to take a more planning-based approach this time. So for this prototype, I want to get some basic combat working and at least a very bare bones gameplay loop. The main reason for this is to see whether or not this idea is even a good one, which is quite important for a game. Now for the question burning in pretty much no one's mind. What tool or game engine have I chosen for making this game, or at least this prototype? And it is Jai. Wait, what? Jai? I've literally never heard of that before. Well, it's a programming language. More specifically, it's a game programming language. And it's as low level as C, not C++, basic old C. Now I can already see people going into the comments to spout out 10 reasons to use Unity or Unreal or some other game engine. And I have used Unity before this for one of the projects that I mentioned before, but I did find it way too bloated for my liking. That's the answer to why no game engine, but what about the question why Jai? It's not even publicly out yet. Well, I got into the beta and looking around in the standard library, it's got everything pertaining to game dev already. It's like a better C with Raylib built into it. Also, I've always enjoyed programming low level, so that's another contributing factor. In the background, you can see me planning out some things, and probably not everything I'm writing down will make it to the final game, if it ever gets finished that is. But it's way too early to tell what works and what doesn't, so I'm just writing anything that comes to my mind. Anyways, that's enough rambling. I should get to programming. So I decided to go ahead and write some code. Here I wrote a little 2D batch renderer. Window creation and OpenGL loading, everything is provided by Jai, which is amazing, to be quite honest. So the renderer API is quite simple right now. Just begin frame, pushing quads, end frame, and it just gets batched behind the scenes. If I go ahead and compile, it compiles quickly. Running, you can see the quad in the bottom left here. So I've just been working on some gameplay stuff for the major prototype that I'm building currently. So I had to use the input module to get user input, and now I have a player controller and a basic sword. So you can see here I can move around. The camera also follows me. If you notice, it's quite subtle, but the camera slightly lags behind the player. This is because I'm tweening between a target and the current camera position, so it's nice and smooth. I can aim my sword and swing, which is also tweened with an easing curve, so that's looking quite nice. Here's the gist of how easing curves work. The most simple easing curve is the lerp, that is the linear interpolation function, which looks something like this. However, this looks quite snappy. Human movement normally isn't this straight curve that starts and stops immediately. So, we can use this lerp as the basis of our next step. If you notice, the lerp takes in a value t. This t value is supposed to vary between 0 and 1. In the normal lerp call, we simply pass through the 0 to 1 t value straight to the lerp function. But what if we modify this t value to not just be a simple x equals y curve, but instead something more interesting? For example, here's what my sword curve looks like. You can see here I'm not directly passing through the 0 to 1 t value into the lerp. Instead, the t value is getting modified to this peculiar function called the easing function. With this modification, you can see that the swinging looks a lot more authentic and smooth. Let's graph this particular easing function with the t value being represented by the x-axis and its corresponding output O as the y-axis. This curve is a lot more interesting than just a diagonal line, but if you compare, they still both pass through the points 0, 0 and 1, 1. This is quite important because it signifies that you're easing from the start to the end with values t between 0 to 1. For an easing curve, the path you take is up to you, as long as the function passes through 0, 0 and 1, 1. The slope of the easing function, that is, the derivative of the function with respect to t, denotes the speed of whatever it is you're interpolating. In this case, you can see that the sword swings with an initial speed, slows down slightly as it goes, then it actually overshoots the target and corrects back to the right spot. This same curve also animates the rotation of the sword around its center, so you can see that easing functions are quite flexible. If you're looking for more interesting easing functions, you can check that out on the website easings.net. So I've just been setting up textures in the batch renderer, and it's finished now. I made a few sample textures in the style that I want this game to be in. You can see here, it's like a cardboard style, kind of. These are quite obviously not the final textures. These look quite bad, but you can see that I can render these, and it's all done in one draw call, so that's really good. But that's gonna be it for today. This Devlog one has been quite successful. I've gotten a lot of stuff done, and I think the plan for the next Devlog would be actual enemy spawning and collision detection so that I can hit the enemy and stuff. So thank you guys for watching, and I'll see you next time. Goodbye.